Morning students. So today we are going to start third unit electrochemistry. In this we will be revising what you have done in 11th standard in the redox reactions chapter, that we will be revising. So only one topic we will be discussing in this today, which is electrochemical cells. Okay, now see, you have done in 11th standard redox reactions. There are two types of redox reactions: direct redox reaction and indirect redox reaction. Okay, so what was there? Direct redox reactions means when oxidation and reduction take place in the same container, then it is called direct redox reaction, and if they take place in different containers, then it is called indirect redox reaction. So here we will be dealing with indirect redox reaction. Okay, here reduction and oxidation will take place in different beakers. Okay, now we have taken one equation, or we can say one redox reaction in a particular electrochemical cell. The reaction is zinc plus copper 2 positive, it gives zinc 2 positive plus copper. Okay, this is zinc copper electrochemical cell. Now there are two things which we must know. One is electrochemical cell and another is electrolytic cell. Electrochemical and electrolytic cell. So electrolytic cell is just a reverse of electrochemical cell. In electrochemical cell there is conversion of chemical energy into electrical energy, and its reverse is electrolytic cell. So in electrolytic cell, electrolysis process occurs. Okay, there what we do, we provide electrical energy and there is some chemical change. Okay, now but today's our topic is electrochemical cell. So here it is the device which converts chemical energy into electrical energy. Now it is termed as Daniell cell also, it is called voltaic cell also, it is called galvanic cell also, or in general it is called electrochemical cell. Okay, now in this, as we said, that two processes occur in different beakers. So those containers where a particular reaction occurs, that is called half cell, or we say there occurs reduction half reaction or oxidation half reaction. So two half cells combine to form an electrochemical cell. Now in this case what is done, our electrochemical cell is zinc copper electrochemical cell. So here there are two half cells in which two half reactions occur. In copper half cell this reaction occurs, which is called reduction, and in zinc half cell this reaction occurs, which is called oxidation. So combination of these two gives us overall cell reaction, or the reaction occurring in the complete electrochemical cell. Now let us look at zinc copper electrochemical cell. This much portion which is on our left, that is zinc half cell. This much portion is copper half cell. Now what is a half cell? When we take a particular metal rod and we dip it in its own solutions, just like here we have taken zinc rod and this solution contains its ions, means it contains zinc 2 positive ions, then it becomes one half cell. Similarly, this is copper rod and this is the solution which contains its ions, so its ions are copper 2 positive, so this is another half cell. So now when we join these two externally, this is external connection, and with the help of salt bridge, then with the help of salt bridge, functions of salt bridge you have done earlier. Salt bridge, it connects the two half cells, just like here you can see, and secondly it completes the electrical circuit. Okay, electrical circuit is like that, from where we start we must reach at that particular point after moving throughout all the components. So salt bridge completes the electrical circuit. Now this is also called Daniell cell, or we gave another names galvanic cell, or we called it voltaic cell. So there is possibility of a large number of electrochemical cells depending upon which two half cells we are taking. Okay. Now from this diagram, one more thing you can see. When the process starts, electrons start moving from this end to this end, and we know direction of flow of electrons is just reverse the direction of flow of electric current. So electrons are moving from left to right, and current is moving from right to left. Okay. Now one more thing, when we apply, see, this thing is E external, this is E external. Now when we apply certain external potential, see, this is the apparatus which we have used here for applying external voltage. Externally we will be supplying some voltage. Okay. Now when external opposite potential is applied to the galvanic cell and we keep on increasing it slowly, then what observations are there? First of all, when we are increasing external potential slowly, then whatever reaction was going on in this cell, whatever half cell reactions were going on, they will keep continuing, means they will keep on as it is till the external voltage reaches the value 1.1 volt. 1.1 volt is EMF of this cell. Okay. So what is EMF? That will come in this session itself. So when it reaches the maximum value, or we can say EMF value, till that point it keeps on working. Now when this value is reached, then no reaction takes place, means till 1.0 volt it will keep functioning, but when the value will be 1.1 volt, then the reaction will stop. Okay. Now what all things happen when the external potential is less than cell potential? We can say for this whole cell potential is 1.1 volt. So if external potential is less than cell potential, then normal procedure, whatever we have done, that goes on. Now what is the normal procedure? Electrons start moving from zinc rod to copper rod, and current flows from copper to zinc. Okay. And then what happens? Left side is oxidation half cell, so zinc undergoes oxidation. Okay. Similarly, right side is reduction half cell, so reduction takes place at the right cell. Okay. So this keeps on decaying and this keeps on increasing. So this is the process which keeps on occurring, which used to be earlier before applying external potential. Okay. Now if we do something else, what something else? If we have taken external potential as exactly 1.1 volt, then what will happen? Then no chemical reaction will occur. Okay, then there will be no chemical reaction, neither oxidation will occur here nor reduction will occur here, and no flow of electron from this side, no flow of current from this side. Okay. So this will be the situation when external voltage is equal to cell potential. Here cell potential value is 1.1. Now if we increase the external potential than cell potential, then what will happen? Then reactions will start, but those reactions will be reverse as expected earlier. Okay. Now what reverse means? Reverse means previously this was decaying or it was undergoing oxidation. Now what will happen? Now copper will start dissolving, it will start as undergoing oxidation. Okay. And it will start undergoing reduction, means those ions which were present inside this, those ions will undergo reduction. So our anode half cell will become cathode and cathode half cell will become anode. Okay. Now current direction and electron direction will also reverse. Okay. So this is what happens when external potential is more than cell potential. So three things we have to remember. When external potential is less than cell potential, then same reactions keep on occurring. When external potential becomes equal to cell potential, then no current flows in the circuit and there is no chemical change. When external pressure is greater than cell potential, then the cell behaves as electrolytic cell, because what is going to happen now, the reverse reaction is occurring, so there will be a reverse reaction, or electrolytic cell, it will become electrolytic cell rather electrochemical cell. Okay, so this is what will happen with the effect of external voltage. Now let us remember how to remember that which sign is to be given and what do we call. Okay, now see, this is general structure, or here we have taken zinc copper electrochemical cell. So when we take solution concentrations as 1 molar, then EMF value becomes 1.1 volt. Okay, now we have to remember a word LOAN, LOAN. LOAN means L stands for left, O stands for oxidation, A stands for anode, N stands for negative. It means that whichever half cell we have placed on the left side, that is containing rod which is acting as anode, and that rod is negatively charged and oxidation process occurs there. Now whatever we have said for left side, reverse will be true for right side. Means in right side reduction will occur, that will be cathode and that will be positively charged. So with one word we can remember the charges and the processes occurring at the different half cells. Okay, so LOAN is to be remembered. Now how it functions. Now see, this is zinc rod. Zinc rod gives zinc to positive ions. Okay, and electrons released start moving from left side to right side. Okay, now when they reach here, in the solution there is presence of copper 2 positive ions. They gain electrons and they start depositing on the copper rod. Okay, so the process of oxidation is this and the process of reduction is this. When we combine the two, we get net reaction as this: zinc plus copper 2 positive, it gives zinc 2 positive plus copper. Now the important concept related to electrochemical cell, EMF of the cell or electromotive force of the cell. Now we can compare it with the waterfall. Okay, now see, in waterfall what happens, water flows from up to down spontaneously. It doesn't require anything else. It is natural process. So what is happening there? Water at higher level has high potential energy and water at lower level has lower potential energy. So what we have seen, we are seeing the movement from higher energy to lower energy. Similarly, when we talk about two half cells connected, then electrons only spontaneously flow from one way in the redox direction, from higher to lower potential energy. Okay, so movement of electrons is from higher to lower potential energy. Okay, now mathematically how can we see it? EMF of the cell, the potential difference between the two electrodes is called the cell potential and is measured in volts. The cell potential is the difference between the electrode potentials of the cathode and anode. It is called the cell electromotive force of the cell when no current is drawn through the cell. So you can define like this also: EMF is the EMF is when no current flows or no current is drawn through the cell, or we can say when external voltage is equal to cell potential, then there is no flow of current. So that time, that much is called EMF of the cell. That much external potential will be equal to EMF of the cell. Now, if we talk mathematically, then cell potential E cell stands for EMF or electromotive force of the complete electrochemical cell. Then it will be given by E right minus E left. E right means cell potential of the right half cell. E left means cell potential of the left half cell. Okay. Now look at this. If this is the cell, then this is left cell, this is right cell. Okay. Now E cell for this cell will be equal to E right minus E left. So right side cell is silver one, this, and left side cell is copper one. So E right minus E left. Sometime we use E naught symbol also. Okay. So that means under standard conditions, or we say it is standard EMF of the cell. So mathematically values are same. When we talk about standard, then it means the concentrations are 1 molar and it is temperature is 298 Kelvin and pressure is 1 atmospheric. Okay, so if these are the conditions, temperature is 298 Kelvin, pressure is 1 atmospheric and concentration of solutions is 1 molar, then the EMF of the cell is termed as standard EMF and is denoted by E naught. Now whatever we have done till now related to electrochemical cells, you have to solve these home assignments. Okay, thank you.